Okay, cool. So welcome everyone. This evening we are going to be going over correlation, which is actually much simpler than the equation makes it look. But the main thing I want to make sure that you guys understand by the end of the session is how to interpret the correlation coefficient. That is the most important thing. Okay, so that is what the little quiz I've made will be about mostly, and then obviously just some definition kind of questions. And yeah, so let's just get going. I will go through what is correlation, how to interpret it, and then we will do a little exercise for calculating it as well, just in case that does come in to your exam. I still haven't received a brief, so I don't know yet. There's a rumor that there'll be about 20 marks of the exam will be on stats. We don't yet know what that means, if it means calculations or if it means interpretation. I think it's going to be interpretation. Okay, so that's not actually a huge chunk of the exam, especially because if you look at the past papers, it's usually out of about 120 or 150, so it's less than 20%. It'll be all right. Okay, anyway, moving on. So, correlation. The most important thing to remember about correlation is you're measuring a relationship. You're measuring whether there is a relationship or not, and you're measuring the strength of the relationship and the size of the relationship. Okay, the important numbers to keep in mind are that your answer will range from -1 to 0 in the middle and +1. Okay, so if you do calculate it and you get a number that's either on the left-hand side of -1 or the plus-hand side of +1, you know you've done something horrifically wrong because a correlation has to fall within this range. Okay, so I have it on another slide, but 0, if you get an answer of 0, it means that there is no relationship between the variables. Okay, so different types of correlation. Oh, I'm sorry, this blue is lighter than I thought it was. I'll change it when I upload them. So you get different things you see with a correlation. When a correlation is positive, it means that the two variables increase or decrease together. So when x goes up, y also goes up. And that's what creates that line going to the top right-hand corner, that linear diagonal line, as if there's a positive correlation. Okay, if you have a negative correlation, the line on the graph will go the opposite direction. It will start at the top of y and go down towards the end of x. And that's because, and this can go either way, but it can either be when as y increases, x decreases, or the other way around, as x decreases, y increases. Oh no, wait, that's the other way around, apologies. So if y is high, x is low. That makes the negative. So like if this dot, you can see if this was 10 up here and this is 1, if x is 1 and y is 10. So as y increases, x decreases. Or one variable increases, the other decreases. That means it's a negative correlation. Okay, and then obviously zero correlation means that there is no relationship between the variables, no statistically significant relationship. Okay, and then the other thing to point out is on the scatter plots of these graphs, how densely packed the dots are shows you the strength of the correlation. So if the dots are kind of not really grouped super strongly together, but you can still perceive a linear line going through them, there is still a correlation, but it's a weak one. Okay, and then you can see like in this top left and top right hand pictures, the dots are much more densely packed around that line. So that would be a strong correlation, either positive or negative. Hi Jude, no worries. Okay, so are there any questions about looking at a scatter plot and deducing the type of relationship that exists? Excellent. Okay, so another very important concept that we need to deal with is correlation versus causation. So you probably would have come across this concept at some point, particularly in journal articles that talk about correlation, but it's not a causation. So basically what the thing is that there can be a relationship between two variables, but it doesn't mean that A causes B to happen or X causes Y to happen. That would be a causation. So that's what that means, a cause and effect relationship. Correlation simply explains whether there is a relationship. Okay, you can't say that if A happens, B will happen. Okay, that's actually just a very important concept to remember in academia in general and life. Okay, everyone good on this? Is there any confusion around the difference between correlation and causation? Great. Okay, so how do we calculate R? Now, in the real world, you literally just put your data into a computer and it spits out a value at you. However, it's good for you to understand, to work it out, how this comes together. So we again have a table, and this is what your little table will look like if you are asked to do this and you're given a set of data. So you have x, y, x squared, y squared, and then xy. And you'll see that these are all of the values that are in the formula. I know the formula looks very intimidating, but when you break it down step by step, we're going to do it together now. It is all okay. Just remember to take it one step at a time. It's an extremely fun little formula. Okay, so they will, if you have to calculate something, the formula will be provided to you. Okay, so you don't need to try and memorize this ridiculous thing. R is what the Pearson's correlation coefficient is denoted as. So R being correlation. It's just the symbol that they use to denote that. Okay. So again, just to reinforce the idea of the independent and dependent variables, if we have a scenario here where you're trying to see if there's a relationship between test scores and the number of cups of coffee the person ingests before the test, which one, okay, I've actually told you which one, but anyway, can you see how X is the independent variable and Y is the dependent variable? Okay, because the dependent variable depends on the independent variable. The independent variable is what you're measuring. Dependent variable is what we change. Is everyone, how do we know that? What do you mean, Cheryl? How to choose which one is the independent and dependent? Okay. Okay, so in this scenario, I've just put in this table. The two variables are test scores, like in a class, like your guys' test scores if you had to do a quiz. And then if I did a survey and said, well, how many cups of coffee have you had today? And you gave me answers, that would be the second variable. So the variables are just denoted by X and by Y. Okay, that's just what the X and Y mean. It's just giving a algebraic symbol to the variables. And they're different because they're separate. Okay. So then deciding which one is the independent and dependent, that's the important step. So if you just remember this little phrase at the bottom, it will help you. So the dependent variable depends on the independent variable. Okay, and also what that's so that when you think about that for a second, it makes sense because the dependent variable is what you manipulate in the experiment. It's what changes to see what the thing you're measuring, what happens to the thing you're measuring. So we would assume, we would hypothesize, just by knowing what caffeine does to the average person, increases concentration, that if there's more caffeine, there possibly would be higher test scores in X. So that's how you can deduce the independent variable what you're measuring, and the dependent variable, what you change. Does that make more sense? Awesome. Okay, so interpreting R. If you are given R, this is how you interpret it, even if you aren't given a graph, okay? So remember again, just to emphasize this, it has to range between -1 and +1. Okay, so this is the important rule to remember. The closer it gets to 1 on either side, the stronger the correlation is. So the closer your number is to 1 or -1, the stronger your correlation is. The closer it is to 0, the weaker your correlation is. And if your answer is ever 0, it means that there is no correlation. Okay. If your answer is ever -1 or 1, it means that's a perfect correlation. So that would be the strongest that it can be. It's a perfect correlation. Okay. So I heard some bleeps go on here. What's going on? Yes. Okay. What? Okay. So if you get a question, like you have a couple in the quiz I'm going to do just now, and they give you a scenario, they say, okay, these are your variables, someone did a correlation, and the answer is R equals 0.3, for instance, C on this graph. Okay. So if you don't see the graph, so if they don't give you the graph and they just give you R, this is what I'm trying to show you now how to interpret that. So 0.3 is on the lower end, right? It's quite close to 0, as opposed to something like 0.8, which is a much higher, closer to 1. So that would mean that because there is an answer and it's not 0, it means there is a correlation, but it means that it is a weak correlation because it's a low number, and it's a positive correlation because it's a positive number. Okay, so that's a little cheat for you. If your answer is a positive number, it's a positive correlation. If your answer is a negative number, it is a negative correlation. Okay, so let me ask a question quickly. If I calculated R and the answer was minus 0.6, how would you describe that correlation? What would be the size and the strength of that correlation? Yeah, so remember, if you're ever asked to interpret R, you must always give all of the answers. You must say firstly, you must say it's a correlation, and then you must say the strength, and you must say the direction. So yeah, Carl, you're right. It would be a moderate negative correlation. Okay. No, yes, I said negative 0.6. Okay, so there are basic rules. There's a table in your workbook, and I've got it on a slide just now for when I do the activity with you, is that you can basically say that if it is below 0.7, it is either weak to moderate. If it's above 0.3, and below 0.7, that's moderate. Okay, it's 0.3 and under, you can say it's weak. And then the same on the other side. 0.7 and above would be a strong relationship. But there is a little table, okay? So that's really the rules that you need to just remember. Okay. And yeah, always just remember to mention all of the characteristics. Okay, so what is the point of this? The point is to find out if there is actually a relationship, and the whole idea, you would be testing a hypothesis, right? Okay, so in this situation, and this is where the activity is going to come in, you are given a research question. Okay, is there a relationship between students' academic performance and the hours spent in the library? Okay, so you can imagine that how this data would be collected would be, you can look at records obviously to see students' performance on a test, and then you could send out a survey to ask them how many hours they spent in the library that week or whatever time frame you give, okay? So I want to draw your attention to the hypotheses. Okay, so when you are asked to give an hypothesis, you must always provide a null hypothesis, which is denoted as H, and there should be a subscript, but for some reason on Canva you can't make subscripts. It's like, really? So where the H is a little one at the bottom, okay, so H0, and then the alternate hypothesis, H1, okay? And they are very simply the converse of each other. The null hypothesis is always the negative. So it's the assumption that there is no relationship between variable A, which is the student's academic performance, and variable B, the hours spent in the library. Let me ask you guys a question. Which is the independent and which is the dependent variable in this scenario? Okay, we have a mix of answers, so let's go back to the reasoning. The dependent variable depends on the independent variable. So the correct answer is the dependent variable is academic performance, and the independent variable is hours spent in the library. Right, does that make sense? Or am I confusing myself now? Okay. Okay, sure. So the thing you are measuring, oops, sorry, I think my mic cut out for a minute there. Can you guys hear me? Yeah, okay, cool. Yeah, there's a video on Learn that is very helpful. Okay, so the dependent variable depends upon the independent variable. So you always ask yourself, what am I measuring? And what am I looking for that to change that has an effect on the thing I'm measuring? Okay, so the independent variable is what you're measuring, and the dependent variable is what you change. Does that make sense? It takes a little bit of time for it to make sense. So let's use the example here where what in the activity we're about to do. Okay, the dependent variable is the grade received, and the independent variable are the hours. Okay. Yeah, it'll sink in. It'll sink in. It will. It's just over time. Okay, so what we are going to do is we are going to calculate. These are the results. So let's say we looked at this group's test scores, and these were the results in percentage out of 100. And these were the answers from the survey, how many hours they spent in the library that week. Okay. I pre-drew this table on the whiteboard, and I'm hoping it's still there. Yes. It was going to be very frustrating. Okay, so I think you guys can actually, you have permission to draw on the whiteboard. So someone just try and do a squiggle on the side here to check. Excellent. Okay, fantastic. Now we can split up the task. Okay, so I need a volunteer to please work out x squared. Okay, Kelly's doing x squared. Who wants to do y squared? Don't all jump at once. I will just... Okay, Sarah's doing y squared, and who wants to do xy? So x times y. Anyone? Anyone with a calculator? Jamie, are you there? Oh, you're going to do it. Okay. Oh, shocking. You have a computer, though. That's a calculator. No, don't worry, Cheryl. Okay, yeah, cool. So we have xy happening as well, and then I'll put the sums in at the bottom. I'll work them out earlier. And then we can check as well. Oh my goodness, who did that? Who's destructive? Why do I feel like it was Jude? Okay. Don't stress, I'm erasing it as I can. Maybe it's a connection problem, Kelly. You can just type them here, and then we'll... Oh, maybe that's because I was trying to rub out all the lines that were drawn. Try again now. I thought doing it this way would save time. You can also input text, hey? Lilo, are you managing with the XY? Nothing's coming up yet. Oh, there we go. Okay, it's starting to come up. Okay, I'm gonna go and put the sums in. Anyone is obviously welcome to check me. Are you helping out there, Sorrel? 3, 8, 9. Okay, there we go. We have all our values. And most importantly, we have the sums. Okay. So after doing that, you just add up all the columns, and that's the number that I've put in the bottom there. All right, just for anyone who didn't follow that. Excellent. Okay, so everyone just take a screenshot or a picture of the screen so you can follow on the next step. I just need to rub it out so we can do the equation. Let me know when you're ready to go. Okay. Okay, now let's write out our complicated equation. This is probably going to be a bit messy. Let me lower the point on my thing. Okay, I'm going to start on the far left in case I need the right-hand side. So R equals N. Okay, so remember N is the number of responses we have. In this case, it is 8. Okay, when you have a value next to the bracket, it means that everything in the bracket needs to be multiplied by that number, just in case anyone needs a refresher on that. Oh, gracious. Sometimes I think if I just had to zoom in on a real whiteboard on camera, it would be easier. Okay, the sum of x, y, minus x while I'm writing out this equation, if you guys want to go ahead and attempt it on paper, if you're there, so we can check just now, that's cool. Ooh, okay, square root of, now this is where it gets a bit complicated and important to remember. So it's n, okay, times, and now another set of little brackets, the sum of x all squared. Okay, no, this one is inside. The sum of x squared. Okay, inside the bracket, this formula is in your workbook and obviously on the slides. The sum of x all squared. Okay, so those are two different numbers, and I'll emphasize that again. Okay, this dot means times. And basically the same thing, but with y. Okay. I know, it's beautiful, isn't it? They should do a font after me. Okay, now we start plugging in our values. Okay, so n, easiest one, is 8. Okay, let's open up the brackets. So we worked out the sum of xy to be 3899. Okay, then we have a minus the sum of x, which was 556. Okay, multiplied by the sum of y, which was 53. Okay, all over, and the square root is always what makes it so messy, but just never forget the square root halfway, okay? Open up the big bracket, 8, little bracket. Okay, so the sum of x, and then, okay, the sum of x squared first was 3,995 2. Yeah, so it's always worth double checking this stage when you're doing it, because if you make a mess here, it is unfortunate later. Okay, and then the sum of x, and then you square that number. So 556 squared is, I'll save you the trouble, I worked it out earlier, 309136. Okay. Now times the same thing but for y. So we have 8. Okay, is everyone following where I'm getting these values from? All from the table that we just worked out. You're just substituting the numbers for the symbols now. Whew, okay, let's do it step by step, starting with the top. So if you all want to work it out with me, what is 8 times 3899? Okay, and then if you multiply 556 by 53, you get 29,468. Okay, first step done. Let's now do the bottom first steps. So what we're going to do first is we're going to do these little multiplications in the table. Okay, so 8 times 39952 is, you'll just have to trust me on this unless you want to do it, 319616. Okay, and then minus, that number is just the same, okay? And again, I'm breaking down each and every step because it's always best to show you're working so you can get the most amount of marks even if you make a mess up. Because if you leave out a 0 or something, the marker can at least give you marks for your logic. Okay, that's very important. I know it's tempting to just plug it into the calculator, but trust me, you don't want to lose those marks. It happens a lot. Okay, 3240 minus, that number will remain. Okay, next step. Everyone following? I lost you. You're all fallen asleep. Okay, doing the next step would be at the top, this number minus that number. We get 1724. It's scary how straight most of that line was. Okay. Next step, let's do this subtraction in here. So, sorry, people are calling me. They forget that I teach in the evenings. Okay. $319616 minus 309136 equals 10. Sure, Kelly. To check. Yeah, pop it up in the chat and then we'll do it now. And then times, no, I forgot to close this bracket. This minus that equals 431. We're so nearly there. Okay. So then we end up with 1724 over the root of this times that, which is this very large number, 451,688. Equals, I don't know, space here. I'm going to carry on the right-hand side. Okay, so now equals, I don't know, space here. I'm going to carry on the right-hand side. Okay, so now you could just do this in one step. It would be fine on your calculator, but I'm just going to break it down again so that everyone can follow the logic. Okay, so it's 1724 over, now you work out what the square root of this very large number is, and it is 2 125.29. Okay, and then you do the final step of that divided by that, and you get the answer correct, Kelly, 0.8, and yeah, just keep it 0.81. Okay. Phenomenal. Now, this is R. Everybody following that? Was anyone following along that didn't get that? It is the right answer, so okay. Fantastic. So now let us head back to the rules so we can make a decision. But in the meanwhile, while I swap over, please describe for me what happens when our answer is 0.81. Oh, I need to go back to the slide, okay. Anyone else want to weigh in? Just to make sure we're concentrating? Okay, correct. A strong positive marked correlation. Yeah, a significant, strong positive correlation. Correct. Okay. So now let's do the final step. What do we do with the hypotheses? Okay, so the null hypothesis was that there is no relationship. And the alternate hypothesis is that there was a relationship. So do we accept or do we reject the null hypothesis? Feels like a game show. Deal or no deal? Reject, absolutely. Okay, does everyone follow that logic? So we have concluded that there is a relationship because we found a strong positive correlation. Woo! Okay. Questions? There must be questions. Any questions at all? Yeah, Lesedi, sure. We reject the null hypothesis because we found out that there was a relationship. Right, so you just decide which one was true based on your results. So H is false because we decided there was, right? H1 is true, so that is what you do. You accept the alternate hypothesis. Yeah, Kelly, to be honest, it's true because you can get method marks for working out, even if you get the final answer wrong. I am 100% sure because they fought over it last year. But I will even send an email tomorrow to 150% be sure. Okay. But all of the on-campus educators have said that you will get the formulas. It's just completely unreasonable to expect you to remember them because honestly, you just don't even know what the formula is in real life. It's pointless with computers. Any other questions before we do our fun quiz? Oh yes, shared variance. Okay, so shared variance tells you what the variance is between the variables. So it's in your workbook. Okay, so the shared variance is r squared times 100 because you turned it into a percentage. Okay, so you would square r, so 0.8 squared. Let's just work it out. 0.81 squared is 0.66, so that would be 66%. Okay, so if they ask you that and they give you a value, it's very possible they could do that because it's a very simple calculation, right? So you just remember that shared variance in a correlation is r squared times 100, and that is a percentage. So then you would say that for this example, there's a 66% shared variance. Okay. Okay, Okay, now let's do the quiz. I feel like Sorrel has chosen violence today, so I hope you're ready, Kelly. Those of you who haven't come to the session last night, we had quite a a rivalry developing. Okay, let me share the clickable link for you. Okay, everybody head over to that link. No, Cheryl.
Sorry.
Yeah.
Sorry, can I just ask you a question just about that shared variance?
Sure.
What did you say again? Is it the percentage of a shared relationship or the shared variance?
Yeah, so what you do is you use it to understand what percentage or what fraction, what proportion of variance that the two variables have in common. Honestly, like in real life, this isn't really often applied, and so
Okay.
it's less likely that they'll ask it to you, but if they do, that's what it means. Okay, the definition is there in your workbook, so do go and remember that as well.
Okay. And then just, I know I'm probably jumping the gun here, but then if you go on to the hypothesis testing, which is the significance, does that relate to t-testing?
So hypothesis testing is a process that you do in statistics, where that's what we just did. We tested our hypotheses, and then you also do hypothesis testing with t-tests.
Okay, because the next, it says you need the direction, the size, the shared variance, and then it says significance. And then this can be answered by conducting hypothesis testing. So as I'm just saying, is that t-testing?
No, hypothesis testing is what you do. You determine the significance via hypothesis testing. And what they mean, and I know it's a bit vague, but what they mean is that process of comparing your answer and then comparing it to your hypotheses and deciding which one you accept or reject.
Okay, so do we need to work that out? Because I know that's a little bit confusing for me with the decision rule or whatever it is when you reject the null hypothesis, depending on the reserved t value and the critical value and what have you.
Okay, so that's for next week. That's the t value and critical values comes in with t-tests, yeah. With correlation, all you worry about is the R and the -1 + 1 rule, yeah.
So if they ask us for correlation, we don't have to worry about significance unless they ask us for significance, what the significance of the relationship is.
Yes. Yeah.
Okay. Thank you.
Absolutely. Okay, any other questions? Okay, are you all managing to join? I'm going to get my dramatic music ready. It just makes it more fun. Okay, are we all ready to go? Okay, we're going to start. You have 20 seconds to answer each question. Oh, Cheryl, you sneaky. I thought you were sitting this one out. Nice, well done. Oh, guys, we're letting Kenny run away with it again. Okay, those of you trying to catch up to the top, remember you get more points for answering quickly, but obviously correctly. This is a bit of a sneaky one. Ah, remember it said causal relationship there. That's not what you're looking for with the correlation. No, my dog is just singing along, Sorrel. Okay, I think this is the last question. Oh no, he did it! Ah. Well done, Sorrel. Well done. Take a bow. Very well done to Kelly and Lilo as well. Okay. Awesome, guys. Well done. I hope that this was beneficial to you, this collab. If anyone has any more questions, now would be the time in the next 2 minutes. But otherwise, that is it for this evening. So 0 is no relationship. If your answer is 0, it means that there is no correlation. There's no, yeah, it was a tricky one.